Hey everybody, today we're going to take a polynomial description, which we have right here, and we're going to turn it into an equation. Last video we took graphs and turned them into equations. Today we're going to see if we can take a description and turn it into an equation. You're going to see a lot of similarities. I'm going to go right to creating an equation with that y equals, and I'm going to use that factored form or that intercept form where I'm using parentheses. So I got a fourth degree polynomial. I could set up 4 sets of parentheses if I wanted to jump right to it, but I'm going to wait and see what the roots tell me as I go through this problem. So if one of the roots is at x equals 4, what that means is one of the points is 4, 0. So how do I get a root to be at a positive 4? I'm going to make a factor with x minus 4. Think about it. If you plugged in 4, 4 minus 4 will give you 0. That's called a 0 or a root or an x-intercept. So there's how we make 4 happen. How do we make 5 happen? Pretty similar. X minus 5. If you plugged in 5, that would take you to 0. That's your 0, your x-intercept, your root. How do you make negative 2 happen? That would be a factor of x plus 2. How do you make negative 1 happen? That would be an x plus 1. Pretty straightforward to start off. For our second polynomial, we're taking a look at a negative polynomial. It doesn't say roots, x-intercepts, or zeros, but it does give us some key points. If you notice, these are all x-intercepts. There's no y. They're all zeros here. These are your zeros, your x-intercepts, your roots. We're going to do the same thing that we did before. Y equals, how do I make 3, 0 happen? If I put x minus 3, think about what happens when you plug in 3. 3 minus 3 is 0, so 3, 0 is a point. Let's make 6 happen. Pretty straightforward. And make negative 2 happen. What's the one thing that I bypassed or I skipped? How do I make a negative polynomial? Boom, that's a negative stretch factor, negative amplitude, negative leading coefficient, negative orientation. There's lots of words that go for this thing, this number, or this symbol that's out front. For a third one, we've got a positive cubic polynomial. Remember that cubic is an x to the third problem. A positive cubic polynomial that has a root at 5 and a double root at negative 2. We're going to jump right to it. How do I make it positive? Y equals, I need a positive stretch factor out front. So I can just put a 1, or I don't need to put anything special for it. It's already going to be positive when I do my x's. So I need a positive cubic polynomial that has a root at 5, so I'm going to go ahead and make x minus 5, so if I plugged in 5 minus 5, it'd be a 0, it'd be a root, it'd be an x-intercept. And again, this is positive, this is the same as a positive 1 out front here, so I really don't have to do anything special for that right now. Okay? And now I need a double root at negative 2, so I could do this 2 ways. I could do x plus 2, and make a second x plus 2. There you can see I have my cubic, I have my 3 roots. Or a double root is often shortcut, whatever the word is, and it is squared. That means it's a double root. You got another root here with the x, so it's x, another x squared, that's going to make x cubed. That makes our cubic polynomial. For our next polynomial, we've got negative orientation. We've got a triple root at 5 and a root at 0. So a little refresher on some things from the last video. We need negative orientation, put a negative stretch factor, negative amplitude, negative orientation, negative stretch factor, did I say that one? So negative coefficient out front. Now we need a triple root at 5, so we're going to make the root at 5 happen with an x minus 5. And we make it a triple root. Probably don't want to write it 3 times, you could. I'm just going to go ahead and cube it, and now I've got a triple root at 5. How do I make a root at 0? That would be x minus 0. X plus 0 is the same thing. How are you going to see it in a book if you go forward in any kind of math classes? You're just going to see the x. If you plug in 5 here, it's going to give you 0. 5 minus 5. If you plug in 0 here, it's going to give you 0. So that's how you make a root happen at 0. For this next problem, I'm going to give a description here. We're still going to turn it into an equation, but I'm going to ask you to fill in a few extra things describing it, see if we can really get used to some of that vocab that we have in the problem. So we've got some x-intercepts at 4, 0. We can make sure that happens by doing an x minus 4. We got 8, 0. We can make that happen by x minus 8. Just think 0. How can you get 0? 8 minus 8 is 0. And negative 0.5, that is going to be an x plus 0.5 would get us to be 0. So we're good there. What's our degree? We have a third degree. There are 3 x's in that problem. X times x times x is going to give you x cubed. That would be a cubic, so it's a third degree. What's the orientation? There's nothing that was mentioned specific in this one that it was going downwards, so we still have a positive. We assume this is a positive 1 out here, so our orientation is positive. What are x-intercepts? They told us them. They are the same thing as our roots or our zeros. So our x-intercepts would be 4, 8, and negative 0.5. And what is our y-intercept? Remember that every single y-intercept ever happens when you plug in 0 for x. So when you plug in 0 for x, what is the y? What happens when you plug in 0 for x? You get negative 4 times plug in 0 for x, negative 8 times plug in 0, you get 0.5. Negative 4 times negative 8, that would be a 32 positive times 0.5, so multiply that times a half, that's going to give us 16. Our y-intercept is going to be at 0, 16. So a little bit extra in that problem, seeing if we could describe a few things over on the side. We've got another one here that we're going to turn the description into an equation. Let's see if we can also add a few things to the description over on the side. Can we make a negative polynomial? Absolutely. We just put a negative out front of our factors as our stretch factor, as our orientation. How do we make a root at 1 happen? Pretty straightforward by all the other examples that we're seeing now. You plug in 1, that gets you to 0. Let's get double roots at 4 and 5. So double root at 4 would look like that. X minus 4 and another x minus 4. And then a double root at 5 would be x minus 5 and a double root there. What is the degree? Well, if I wrote out all of these x's, there would be an x here, there would be 2 more x's here, 2 more x's here, I would have 5 degrees. It would be a 5th power, it would be x to the 5th, right? X times x squared would be x to the 3rd, times x squared would be x to the 5th. So if I wrote all these out, all the parentheses, I would have a 5th degree polynomial. What is the orientation? It says that it's a negative, so we're going to have a negative orientation. What are our x-intercepts? Those are the same things as our roots, so we've got 1, 4, and 5. So even though it's a 5th degree, we don't always have 5 x-intercepts, right? We have 5 x's if we were going to write out all the parentheses. But it doesn't necessarily mean that we have 5 x-intercepts, right? So there's only 3 x-intercepts that it hits because this is a double, this is another double, that's going to make 4, and 1 more over here is going to make our 5th degree. What's our y-intercept? Think about what happens when you plug in 0 at all these. When you plug in 0 here, you get negative 1. When you plug in 0 here, that's negative 4. What's negative 4 squared? You can think about that as we go to the next line. And plug in 0, that gives us negative 5, and that's going to be squared. So we've got our y is negative 1, negative 4 squared is 16, 5 squared is 25, and we're going to have to multiply those. A y is going to be a negative value, and we're going to have to type in 16 times 25. Let me see if I can break this down in my head. 16 is the same as 4 times 4. So if I did 4 chunks of 25, that would be 100. 100 times 4 is 400 with a negative. Go ahead and double check my math that the y-intercept should be 0, negative 400. So all I did was just plugged in 0 for the x's to see what was the y, what was the y-intercept. We've got something new added in this one. We've got a stretch factor that's included. So we're going to go ahead into our equation with our y equals, and we're going to put that stretch factor of negative 2 out front of our factors. We need a root to happen at -3. If I do x plus 3, that's going to help me find that. Plug in -3, it'll turn it to 0, it'll be one of your roots. I need a double root at 1. So x minus 1, think 0 there, make it a double root, and we've got squared. What is our degree? Focus on your x's. We've got an x, and then we've got another x squared. Or if I wrote this out twice, I would have 3 x's. It's going to be a third degree polynomial. What's the orientation? Take a look at your stretch factor. It is negative. Negative orientation. What are our x-intercepts? We should look for 3, but we don't necessarily have 3 because this one's going to happen and this one's going to happen twice. So we only have 2 x-intercepts. So it'll be -3, which we had up here. Root is the same thing as a x-intercept, and a root at 1 is the same thing. So we got another x-intercept there. What's our y-intercept? Remember, we got to plug in 0 for x. So how do you find a y-intercept? It is when there is no x. So we're going to plug in 0 for x, that gives me 3. Plug in 0 for x, that's -1, and we're going to have to square it. Now we just multiply. -1 squared is going to be just a 1. 1 times 3 is 3. 3 times -2 is -6. Our y-intercept is 0, comma, -6. So there's a stretch factor. I'm going to give you one more for you to try. And here we go for the last one, turning a polynomial description into a polynomial equation. And we'll just go right in order as the information is given to us. We start off with a y equals for our equation. We need a triple root at -2. Let's make the root happen at 2, -2 first. And then we need to make it a triple root, so I'm going to go ahead and cube that. I need a stretch factor of 5. Let's go ahead and put that stretch factor out front. That is multiplying by 5. It's going to stretch it 5 times as tall. And we need a 0 at x equals 1. Remember, a 0 is the same thing as a root, same thing as an x-intercept. So how do I make x equals 1 a point? I need an x minus 1. As we take a look at our degree, remember you should be focusing on your x's, or if you wrote out every single parenthesis, there would be 3 x's here. That would be x cubed times another x is x to the 4th. We would have a 4th degree polynomial. What's our orientation? We take a look at our stretch factor. That is a 5. So our orientation is going to be a positive 5. Right? Positive. So our graph will end going positive. And the question I'd like to leave you is what are the x-intercepts and what are the y-intercepts? There should only be one y-intercept. What are the x-intercepts and y-intercepts? That's what you'll be seeing if you can do on your own. Good luck. Let me know if I can help you out at all.